Okay, here we are on page 9 of quadratics. There's a good example in the book for you to take a look at on page 33, or you can just watch me do the first problem, number 8. Remember, watch me do a problem and then try to do one on your own. So we're going to do A together and then maybe try to do the others on your own. We're going to find various characteristics of the quadratic, and then we're actually going to graph it. So the first thing we're going to do is we're going to find the axis of symmetry. Remember, the axis of symmetry can be found by, that can be found by x equals negative b over 2a, and that is written in the formula sheet. You don't need to memorize it. And number 2, we're going to find the coordinates of the vertex. Remember that we could just take the x coordinate of the axis of symmetry and find the y value, and that gives us both the x and the y of the vertex. To find the axes intercepts, we plug in x equals 0 to find the y-intercept, and to find the x-intercept, we plug in y equals 0. Remember, x-intercept we find basically by doing quadratic formula. And finally, we're going to sketch the quadratic using these characteristics that we found. Basically, the vertex and the axes intercepts is enough. Okay, so let's look at A. So A is x squared minus 2x plus 5. So that means the B value is negative 2, the A value is 1, and the C value is 5. So the axis of symmetry would be x equals negative b, which would be negative minus negative 2 divided by 2 times a, which is 1. So that's basically equal to positive 2 divided by 2, which is just x equals 1. Remember that if you're going to write the axis of symmetry, you need to write x equals 1 and not just 1, because axis of symmetry is not just a number. It is the imaginary line which goes through the middle of the quadratic, the parabola. And because it is a line, it needs to have the equation of a line. Equation of a line, keyword being equation, has to have an equal sign in it. A vertical line is written x equals 1 because the x coordinate is always 1. Okay, now let's figure out what the vertex is. So the way we figure out the vertex is we put the x value of 1 into the original equation, and we get that the y value of the vertex is going to be 1 squared minus 2 times 1, which is 2. Minus 2 plus 5, so that's equal to 6 minus 2, which is equal to 4. So our vertex is going to be equal to 1, 4. What else can we figure out? We can also figure out the axes intercepts. The y-intercept is quite easy to figure out. When it's written in standard form, the 5 here, it turns out to be the y-intercept. Okay, and the reason why is to find the y-intercept, what you do is you plug in x equals 0. If I put in 0 in the two terms which have x's in them, guess what? The only term that's remaining is the last term, which is the c value, which is 5. So I know that the y-intercept in this case happens to be 5. And the x-intercept is a little bit harder to figure out. I need to figure out the x-intercept by doing quadratic formula. Also factoring and other things are possible, but for these first few pages, we're going to concentrate on quadratic formula because that's always going to work. So a equals 0, b equals negative 2, c equals 5. Let's figure out what the x-intercepts are with quadratic formula. It'll be negative b, so it'll be negative minus 2 plus or minus b squared, which is going to be positive 4 because negative 2 times itself is positive 4, minus 4ac, so minus 4 times a, which is 1, and c, which is 5, divided by 2 times a, which is just going to be 2. And remember, negative times negative is positive. So basically, this is going to give me 2 plus or minus square root of 4 minus 20. So it would be square root of negative 16 divided by 2. And square root of a negative number, square root of negative numbers are imaginary numbers, which actually are not a part of this course. So there's basically no x-intercepts, okay? All right, so let's try to graph it and see if we can confirm that to be true. So first of all, for A, y equals x squared, so we're going to graph this, okay? And the first thing we're going to use is the fact that the vertex is 1, 4. So at 1, 4, I'm going to put a dot. The other thing we know is the parabola opens up, right? Because the a value is a positive number, so it's going to open up. The other thing we know is the a value is 1, so we know that it's going to go up at a familiar rate of 1, 1, 2, 4, etc. Okay, 3, 9. All right, and then we're just going to trace between these using blue. And you can see that it's just a parent function parabola translated so that the vertex happens to be at 1, 4. And now we see why the x-intercepts do not exist, because this one floats above the x-axis. It doesn't cross it at all. Okay. Now maybe you could try to do some of these on your own. If you want to continue watching, you may. So let's try this one. This one's a equals -3, b equals +4, and c equals -1. So our axis of symmetry would be x equals -b over 2a. So -4 divided by 2 times -3, which would be -4 divided by -6, which is equal to 2/3. So our axis of symmetry is x equals 2/3. Our vertex would be using this as the coordinate of the vertex. And to find the y coordinate of the vertex, we just take 2/3 and we plug it in to this expression, and we're going to get a terrible expression, right? It'll be y equals -3 times 2/3 squared plus 4 times 2/3 minus 1. And so that would be -3 times 4/9, because 2/3 squared is 4/9. You square both the top and the bottom. And then 4 times 2/3 would be 8/3 minus 1. And then we simplify that. -12/9 plus 8/3 minus 1. And we can simplify the -12/9 because there's a common factor of 3 in the top and the bottom, so that would be the same thing as -4/3 plus 8/3, and I'm going to write -1 as 3/3 so that it would be easier to add these fractions together. -4 plus 8 minus 3 would be 1/3, is that right? So our vertex is going to be 2/3, 1/3. That was a lot of work to find the vertex. Okay. The next thing we're going to do is we are going to find the y-intercept, and the y-intercept we know is equal to the c value, so it's equal to -1. And the other thing we're going to do is we're going to find out what the x-intercepts are, and the way we do that is we use the quadratic formula. So the x-intercept values are going to be -b plus or minus the square root of b squared, which is 16, minus 4 times -3 times -1. And -3 times -1 is equal to +3, so I'm just going to leave out the negative sign. I'm going to write 3 there. And that's all divided by 2 times a, which is -2 times -3. So that leaves us with -4 plus or minus 16 minus 12, which is going to be square root of 4, divided by -6. So that would be -4 plus or minus 2 divided by -6. So that would be, so if I do a +2, it would be -2 divided by -6 would be 1/3. Or if I did -2, it would be -6 divided by -6, which would be +1. And so my x-intercepts would be 1/3 or 1. So let's try to draw some of this now. Draw the axes. And my vertex is going to be 2/3, 1/3. So 2/3, 1/3. Maybe what I'll do is, in order to draw a nice picture, I'm going to divide my graph so that it actually has bigger grid marks. So each one of the grid marks has 3 little blocks in it, and each one of those blocks is 1/3. And then maybe we'll get a nicer picture. So, for example, the vertex is 2/3, 1/3, so that would be like right there, right? And the x-intercepts are 1/3 and 1, so that would be here and here. And the y-intercept is -1, which would be here. And now I'm going to try to draw a parabola through those. And so just using symmetry, I know that the other point here is here, and so on. Okay? Now let's go to C. Okay, now I'm not saying that all this arithmetic algebra is not fun, but I want to show you how to use the calculator too. So C is an ideal problem to show you the calculator method. So let's do it. First thing you're going to do is you're going to take this function, 2x squared minus 5x plus 2, and you're going to type it into the screen y equals. How do you get to y equals? You just press y equals, and then we're going to type 2x squared. The x, you press this key here. Squared, you can press this key here, or you do circumflex with 2, like the caret 2. And then you do minus 5x plus 2. And then I graph it. And then basically it's just copy the graph, but it's quite hard to copy the graph because this grid doesn't even show up, right? So what I recommend is, I recommend that you, after you draw your axes, we're going to look at the table, because the XY table, second table, is much better for getting points that we could graph. So I'm going to graph the point 0, 2, and 1, -1, and 2, 0, and 3, 5. You're thinking, whoa, this is a really weird parabola. How come it's not symmetrical? 4, 14. Okay, that's off the screen. If I want the negative numbers, I just scroll up. -1, 9. Okay, so I can draw it. Oops, I can draw it, but like you said, it's not symmetrical, right? So now I need to find out where the vertex is and things like that. How do I do that with the calculator? Especially this weird one here. It doesn't even show up on the table. It's hard to see where the vertex is because I don't even see symmetry here. To find the vertex with the calculator, you just find the minimum point. The way you find the minimum point is you do second calc minimum, which is number 3, or you can scroll down there and go to number 3. And then you're going to say to the calculator, okay, the minimum point I want is this one here. So I'm just going to put a mark on the left of here and put a mark on the right of here so that the calculator knows which minimum point I want, and then it'll find it. Now, there's only one minimum point, so you're saying, why does the calculator even ask me? Well, the calculator is made to do more complex problems, so that's why it's going to ask us anyway. So the left cursor, the cursor is already in the left position, so I'm going to hit enter as is, and then it asks me what the right bound is, and then I'm going to use the right arrow to move the cursor well to the other right side of the vertex, and then I hit enter, and then it asks me to guess. Okay, there's only one minimum point here, so it doesn't really matter what the guess is. I just hit enter again, and it tells me the minimum is 1.24999, blah, blah, blah. Actually, the calculator uses numerical methods, not analytical methods, not derivatives or anything like that to find the minimum point. So, or it doesn't even use negative b over 2a. Okay, so it looks kind of weird there, but actually what the calculator meant to say is that the vertex is at 1.25, comma negative 1.125. Okay, so the vertex is at 1.25, comma negative 1.125. That's the vertex. What else did we get asked? It wants to know the axis of symmetry. Axis of symmetry is just the x-coordinate of the vertex with x equals in front of it. So that's the axis of symmetry. And the other thing it wants to know is the intercepts, and the y-intercept is quite easy to find with the calculator. You just do trace 0, Trace, where's trace? Trace allows me to move the cursor around with the arrows to find any point on the graph, but it's actually a really bad way to find the y-intercept. We want to find the y value exactly x equals 0, so we just type 0, x equals 0, and then it shows us that the y value at that point is 2, which shouldn't be a surprise because the c value is 2. So the y-intercept is 2. And what are the x-intercepts? Okay, so there's a way to do this with second calc 0, but maybe it's a little bit easier to understand, especially the first time, if I do it using PolySMLT. So all I need to do is put the expression into PolySMLT. Sometime later, I'll show you how to do second calc 0. Go to PolySMLT, hit enter. You're going to do poly root finder, which is how we find the x-intercepts. You say that the order is 2 because we're doing quadratics. You hit next. And then we're just going to put in the coefficients a, b, and c, which are 2, negative 5, and 2, right? So we're going to put 2 for a, negative 2, or negative 5 for b, and then we're going to put positive 2 for c, and then we'll press solve. And the two possibilities are 2 and 1/2. If you want to see them in decimals, you just press this button here, F, what's it called? Floating point or decimal, or fractions or decimal, and you just press the button that corresponds to that, and it changes to 2 and 0.5. Okay, so the x-intercepts are going to be 2 and 0.5. Okay, so that's how you do it with the calculator, all right? And the one down here, one of them we'll do by hand and one of them we'll do by calculator. Let's do the easy one by hand, okay? This is the easy one here. So the vertex in this case, we can find by doing negative b over 2a. Negative b over 2a. And our negative b is going to be, oh, wow, this is kind of tricky, isn't it? Because it's not in the regular order. If we were going to put it in the regular order, this would be first. Negative x squared would be first. So this is actually our a value. Our a value is negative 1. Our b value is what's multiplied times x, which is 6. And then our c value is 0 because there's plus 0 here. Okay? So our a value is negative 1. Our b value is 6. So the axis of symmetry would be negative 6 over 2 times negative 1, which is negative 2. So negative 6 divided by negative 2 is positive 3. So our axis of symmetry is x equals 3. Our vertex would be, if we plugged x equals 3 into the expression, we would get our y, the y coordinate of the vertex. So it would be 6 times 3, which is 18, minus 3 squared, which is 9. And so our y coordinate of the vertex is 9. And so our vertex is equal to 3, 9. And so we have our axis of symmetry, we have our vertex. Let's find our x-intercepts. The way we would find our x-intercepts is we set the expression 6x minus x squared into 0. And then we could do quadratic formula, but this is a really easy factoring job, right? Because, you know, normally I say don't do factoring, but in this case, the factoring is kind of effortless, right? So it factors into, it factors into, 6x times the quantity 6 minus x, okay, equals 0. So one of the solutions is x equals 0. X equals 0 makes that expression 0. And the other expression, or the other x value which causes that to be 0 is x equals 6, right? So now I'm going to draw the graph of the function using the characteristics we have found. The vertex is 3, 9, and the x coordinates, or the x-intercepts, are 0 and 6, and the y intercept is 0, of course, because the c value is 0. And so it happens to intersect the axes exactly at the origin, doesn't it? Now I'm going to draw a sketch for the rest of it. Basically looks like that, okay? It's upside down. Makes sense because the a value is negative, right? Okay, now we're going to do the last one, which looks awful. It's got a fraction in it and everything. let's do this one with the calculator, shall we? So since we're already on PolySMLT, why don't we go ahead and do the last one with the calculator, or the x-intercepts with the calculator. We're going to put -1/4. If you want to put -1 divided by 4, you can, but I also know 1/4 is 0.25, so I'm just going to put -0.25. It's easier to type. B is 2, and C is 1, and I'm just going to solve it, and that gives me, oh my god, look at those horrible x-intercepts. And now you can see why I did it with the calculator. So the x-intercepts are 8.47 or -0.472, and an IB, I try to give 3 significant figures for each one. Okay? The y-intercept in this case, of course, is just 1. And the vertex, let's find that with the calculator too. We're just going to type in, we'll go to the y equals screen. Oh, let's get out of this, shall we? So second quit gets you out of anything. You go into y equals, and then we're going to type in the new function. Make sure that when at the very beginning, if there's a negative sign, you can't use the subtract. At the very beginning, you always have to use the negative sign and not the minus sign. It's different in the calculator, the TI-84. X squared, oops, that's not x squared, it's x to the -1. Let's delete that. So x squared, oh, it already says x squared, fine. X squared plus 2x plus 2x plus 1. Okay. Looks good. Now I'm going to graph it so that I can find the vertex. Remember how to find the vertex? The vertex, sometimes you can kind of see it using the table. If I go to the table, maybe I'm going to see that it's symmetric, and the middle number that is, let's see. Let's see if we see any symmetry here. Yeah, let's see. I see a little bit of symmetry here. I see 4.75, 4.75, 4, 4, 2.75, 2.75. So it's symmetric about 4, 5. 4, 5 must be the vertex, okay? But if I wanted to do it with the calculator, I could, or if I want to do it with the graph, I could find the maximum point here, which would be second calc max, which is option 4, and then I just give it the left bound. That's perfect. It's to the left of the vertex. I'll hit enter. And then I move using the arrow to the right side of the max. I'm definitely on the right side of the max there, so I hit enter again. Guess doesn't matter where it is because there's only 1. So I hit enter again, and it tells me that the maximum is 4, 5. Okay? So I'm going to mark stuff here on the grid, okay? I'm going to put 4, 5. I'm going to put the y-intercept of 1. I'm going to put the x-intercepts of 8.47, which is about 8.5. It's right there. And -0.472, it's about -0.5. And then I'm going to connect them to make a curve. It looks kind of like that. Okay? So that's it for this page. That was a long video, wasn't it?